This session is for OCR FP2, topic is calculus, and we're doing question 6 from January 2011. So let's start by looking at the question. So we've got a diagram which shows the curve y equals f of x, which is defined as x to the power of x for x strictly greater than 0 and less than or equal to 1, and the function is equal to 1 when x equals 0. So part 1 says, by first taking logarithms, show that the curve has a stationary point at e to the minus 1. And then it says, the area under the curve from a half to 1 is denoted by a. By considering the set of 3 rectangles shown in the diagram, show that the lower bound, or a lower bound, for a is 0.388. And in part 3, by considering another set of 3 rectangles, find an upper bound for a, giving 3 decimal places in your answer. It then says the area under the curve from x equals 0 to x equals 0.5 is denoted by b. And we're asked to draw a diagram to show rectangles which could be used to find lower and upper bounds for b, using not more than 3 rectangles for each bound. And it says you are not required to find the bounds. So if we go back to the beginning, so we've got the curve, and it says by first taking logarithms, show that the stationary point is at e to the negative 1. So we have our function f of x is equal to x to the power of x. So I'm going to let that be y. And then we're going to take logs of both sides so that we can deal with the unknown, the x in the power. So that means log of y is going to be equal to x log x. And then we can differentiate. We want to find dy by dx, so we'll differentiate implicitly. We'll get 1 over y dy by dx, and we've got a product rule here on the right hand side, so that will be u times the derivative of log x, which is 1 over x, plus v log x times the derivative of x, which is 1. So in fact we end up with 1 plus log x, and now we want to find dy by dx. So all we have to do is to multiply that by y, which of course is x to the power of x. So we know that the stationary point is when dy by dx is equal to 0. So we can put 1 plus log of x, x to the power of x equals 0. But that is going to imply that 1 plus log x is equal to 0. Since x to the power of x cannot be equal to 0. And that in turn implies that log x is equal to minus 1, so x is equal to e to the minus 1. So just 3 marks for that question. So if we just check on how those marks are allocated, so there was a method mark here for doing our first bit of differentiation, an accuracy mark for getting it in this form, and then another mark for getting and showing that the stationary point, the x-coordinate, was e to the minus 1. So we have part 1. So if we look at part 2, it says we're looking at the area between 0.5 and 1. So we're considering a set of 3 rectangles. So we're looking at this area here, from here. So this is our A. It's the area in here, isn't it? So if we want to find a lower bound, then we're going to take each of these 3 rectangles and we're going to take the point at the left. So our first rectangle, if we think about how we're doing this, so the lower bound then is going to be the sum of 3 rectangles. So 0.2 is the width, and the first one will be 0.5, the height will be 0.5 to the power of 0.5, and then the next one 0.2 times 0.7 to the power of 0.7, and then the third one has width 0.1 times 0.9 to the power of 0.9. And if we simplify that, we get approximately 0.3882. So the area we now know is greater than 0.388. So we have our lower bound. If we do a similar sort of thing for the upper bound, but when we're doing the upper bound, of course, we're going to take the right-hand side of each rectangle. So the upper bound is going to be 0.2. So we're going to take this point here. So we're going to have the rectangle which is slightly above. So it's going to be 0.2 times 0.7 to the power of 0.7 plus 0.2 times 0.9 to the power of 0.9, and the last bit will be plus 0.1 times 1 to the power of 1, which is just 1. So I'll not write that in. And again, that will be approximately equal to 0.4377. So that means the area is going to be less than 0.438, because we were asked to give it to 3 decimal places. So that is an upper bound. So 2 marks for each bit, a method mark and an accuracy mark in each case. So a method mark for this bit and an accuracy mark here, and then a method mark here and an accuracy mark. So 4 marks in total. So if we just have a look then at the last bit, so in this particular case what we're actually doing is we're looking at this area now to the left. So this is our area B, is going from 0 to 0.5. So this is the area we're looking at. So we're asked to draw a diagram to show the rectangles to find a lower and upper bound. So if we start, I've marked on here which is our turning point. So if we take an upper bound, then probably the sort of easiest way of taking an upper bound would just be a matter of drawing this rectangle in here. So the upper bound height will just be f of 0, which is 1. So that would be, this could be our upper bound. Just one rectangle and we would get an upper bound. If we want to do a lower bound, I'll just change the colour so we can draw our rectangles in, then probably the easiest way of finding our lower bound would be just to draw and look at 2 rectangles. So you have this one and this one. So those 2 rectangles, and that would give us a lower bound. This is the turning point, so I'm actually drawing this horizontal line, so this will be f of e to the minus 1. So those would be our 2 rectangles in that case. So there was 1 mark for your upper bound, just in fact it was a statement mark, just a B mark for doing an upper bound, and then there was a method mark and an accuracy mark for your lower bound. Now there will be slightly different ways of drawing your rectangles, but that is possibly the easiest way of doing it, because it did say not more than 3 rectangles for each bound. So we've used 2 for the lower bound and 1 for the upper bound. So in total for that question we had 10 marks for the whole of question 6. So don't forget that if you want to watch further revision videos, then you can do so by going to the Further Maths Support Programme website and following the link.